So hello guys, my name is Ola Shobowali. I'm going to be helping Josh today and tutoring you guys in Chem 232 with alkene and alkynes and reactions that take place. So I can't stress this enough, but you guys, all these reactions that are placed here, it'd be a good idea to pause the video right now and just mark these down, put them on flashcards, put them on note cards. Bottom line is you guys need to be able to memorize these and apply these to your test. If you see something like H2 over PD on your test and it's a 4-part reaction and it's only the first part, that's the whole problem gone. So again, I cannot stress this enough, memorize these reactions. Just going down the list with some of the reactions that you need to know. We have the first one, H2 over platinum. Now what this reaction does, it's a heavy reducing agent. And what that does, it reduces a reaction. It reduces alkenes, double bonds, and alkynes, triple bonds, all the way into alkanes, single bonds. The next up, we have mercury over acetone, Hg over OAC2, over H2O, and then sodium borhydride. What this reaction does is it first creates, pause. I messed up there.
I told you not to say that one.
Okay. All right. All right, now. So what this reaction does is it turns an alkene into an alcohol. It hydrates it. Pause again. All right.
Do the ones that are nodded.
All right. Okay, so what this reaction does, mercury over acetone, it turns an alkene and it adds an alcohol to it at the Markov position. Next up, we have two reactions, one Hbr and the other one Hbr over peroxide. What we need to focus on here is that the one that's just Hbr, it adds an Br or a halide group to the Markov position. And keep in mind, just to know, whenever you're seeing something over peroxide, it's usually almost always going to add something to the anti-Markov position. I'll show the mechanisms on the later half of the video. Next up, we have Br2 over H2O, a hydrohalogenation reaction, and it adds an OH and a Br. We have dilute H2SO4 or H3O+, or even H2SO4 over water. And what's that going to do? It's going to hydrate an alkene at the Markov position. After that, we have BH3 over THF, and that's another hydration reaction. It's going to add an alcohol to the anti-Markov position in this case. And then we have Br2, which just adds 2 bromo groups to an alkene. On our alkynes, our triple bond reactions, we have OSO4 and MCPBA. Please take note that both of these reactions heavily hydrate an alkene. With OSO4, we should keep in mind that both the alcohols that are going to be added are going to have the same stereochemistry, the same inversion, but these ones are going to have inverted stereochemistries for MCPBA. Next up, we have H2 over PD, and just as I said at this reaction is one that reduces all types of bonds, alkenes, alkynes, and produces alkanes. Next, we have Linder's catalyst and NaNH3. Keep in mind that these reactions kind of go hand in hand. With H2 over Linder's catalyst, we will turn an alkyne and promote a cis conformation alkene, while Na over NH3 will take an alkyne and promote a trans alkene. Then we have NaNH2. So NaNH2 in this case, it will act and it will take the H off a terminal alkyne and promote a good nucleophile. This one's going to be one that you're going to see used in many multi-step reactions on your exam. Next, we have Hbr over H2o2. And as I said, H2O2 is going to, all right, pause.
You're doing great.
Thank you. Hbr, H2O2.
It's going to give you anti-Markov.
Okay.
Remember, that's a terminal alkyne. So that one is only primarily substituted versus secondarily substituted.
All right, okay. And next we have Hbr over H2O2. And as I said previously, whenever we see H2O2 as a solvent, it's usually going to make an anti-Markov position on our product, just as it does in this one. And we have dilute H2SO4, which is also H3O, and H2SO4 over H2O, So don't get hung up on those reagents when you see them in an exam. But what it's going to do is going to hydrate an alkyne into an alkene. Next, we have Br2 on an alkyne, and just as it did with the alkene, it's going to produce 2 bromo groups on the hydrocarbon. Next, we have O3CHCl2, and what this is a heavy oxidizing reagent. What it does for an alkyne is going to produce 2 carboxylic acids. So these, again, as I said, these are going to be the reactions and reactions that you need to memorize for your upcoming exam. If you do not know these reactions, it's not going to help you when you see one of these, or when you see one that just includes the reagents and the products and asks for the reagents, or one where it gives you the reagents, because either way, you need to know what they do. And nothing on the exam is going to help you tell what they do. So memorization. As Josh said, I find the best way for memorization is flashcards. So this is how I would recommend studying for these type of reagents. One, you would make 2 different sets. One set is with the reactants and the products, and on the back side is the reagents. So it will help you know which reagents you need to know to get which products. And on another one, you have just the reactants and the reagents. So that set of flashcards will help you know what each reagent produces. Moving on now, we're going to move on to the mechanisms. The first mechanism we have is sodium hydride over H3O+. So we have our alkane. We have our Die Bromo alkane. We see that our bromos are adjacent to each other. One thing that you're going to need to notice, and just a rule of thumb with all organic chemistry reactions, is that your group 1 elements, sodium, lithium, and potassium, what they do is they dissociate in solution. So what that's going to do is going to have whatever it's with. Our group 1 elements, usually comprising of a +1 charge, is going to render this with a negative charge, enabling that to effectively take off an H, a hydrogen. As that does that, the bonds, the electrons in the hydrogen, are going to go back into this bond, producing an alkene. So another OH is going to come, and the lone pairs here are going to attack this hydrogen, resulting in the lone pairs in the hydrogen going into this alkene, effectively producing an alkyne. With this alkyne, it's going to now attack the With the alkyne, it's now going to attack the acid, and as that acid, as it takes the acid, it's going to take one of the hydrogens, reducing the lone pairs to go back into the water, the now produced water. We now have an effective alkene with a hydrogen at one end and a carbocation at this end. This positive charge is going to be attracted to the partial negative, the oxygen, so the oxygen's lone pairs are now going to attack this carbocation, effectively making an alkene with the water group on one end. Water is positive right here, so its extra hydrogen is now going to be picked up by another water, effectively producing our molecule up here. All right, going on to our next mechanism, we have Hbr over peroxide. Now, as I said, when its peroxide is used as a solvent, it almost always produces an anti-Markov position in the product. So this reaction starts with the initiation of peroxide separating its radicals. So we know that there's 2 lone pairs in every bond. The 2 lone pairs are going to be equally divided by the oxygen. So one lone pair is going to go to one OH group, and the other lone pair is going to go to the other OH group, effectively producing 2 OH pairs with each a radical. The radical in one OH group is going to interact with the bond of the Hbr, effectively separating the electrons in here for one to go into the bond formation of this, and the other to go into the formation of Br radical. Radicals are very reactive elements. So the radical here is going to interact with the alkene, effectively producing a Br on the anti-Markov position. This happens because radicals are just like carbocations. They're going to find the most stable position, and a secondary carbon is more stable than a primary. The radical that is now at the secondary position is going to react with the hydrogen radical from the OH, effectively producing our alkane, our bromo alkane. For our next mechanism, we have NaNH2 over M. All right, let me get my footing.
NaH2 over acyl halide.
over an acyl halide.
Similar to Williamson ether synthesis.
All right. For our next mechanism, we're going to have NaNH2 over an acyl halide over an acyl halide with a terminal alkyne. As I said before, Na, one of the group 1 elements, is going to dissociate in solution, effectively producing a negative NH2. This NH2 is going to pull off this hydrogen off the terminal alkyne, rendering these electrons to go back into the carbon here, effectively creating a negative carbonyl group and thus a great nucleophile. This reaction, you're going to see this reaction a lot in SN2 reaction, multi-step reactions on your exam. So over here we have our primary acyl halide. As we know, primary acyl halides are great reagents for SN2 reactions. So this negative of this terminal alkyne is going to attack this carbon here, effectively pushing this iodine out, yielding us a substituted product. We now have a whoopsie.
Just because you just say it, you get the product.
And now we get the product. For the last mechanism we'll cover today, we'll cover an alkene reaction with the Die Bromo group. In these type of reactions, they form epoxides. So the lone pairs in the alkene are going to react with the dibromine. The alkene is going to attack one of the bromo groups, effectively pushing the lone pairs into one of the others, disassociating it. This forms an epoxide with the Br, and the Br having a positive charge on it. The other displaced bromine group is now going to attack one of these carbon groups, pushing this Br over here, yielding a dibromo alkane. Is that all?
Yeah, and I just end
So just, all right. So these are all the mechanisms and all the reagents that you need to know for alkene and alkyne reactions. Again, I cannot stress this enough. To pass and do great in your class, in this chemistry class, heavy memorization is needed. So just make flashcards. You can either write on a notebook, cover, see what you got right, but the bottom line is you guys need to memorize these reactions.